If you look at the stats alone, eating ice cream and murders in New York are positively correlated. This means that the more ice cream sold per person, the number of murders increases. Vanilla bean never seemed so scary, right? Before you stop eating ice cream sundaes to save innocent lives, think about it. Correlation as a statistic doesn't explain how or why the relationship between ice cream and murder exists. It simply shows that it does. Causation makes an even bolder assumption and says that a change in the number of chocolate cones sold will cause a change in the number of people who meet their unfortunate end. This is clearly a big leap. A well-designed experiment will rule out other factors that could be related. So you must ask yourself, what's another variable at play? It turns out that temperature was also correlated with both ice cream sales and murders because the numbers for both spike during the summer months. When it's warm outside, people simply get out of the house more. They're on summer break or vacation and want a cold, delicious treat. Kids hang out unsupervised more. It just so happens that the Freddy Kruegers of the world also get out more during the summer. Before you jump to a cause and effect relationship when a correlation is found, look at how the data was collected and consider other related factors. And go ahead, eat that pint of Rocky Road.
Hello all, we're on page 21 of the notes and we're talking about linear and quadratic regression. Big complicated words that describe kind of a simple concept. Basically, it's a term that describes a way to measure the relationship between two variables. Most regression models begin with a scatter plot that is created from collected data. There are several possible types of trends that can be analyzed looking at data. We're going to focus on linear trends and quadratic trends, but that doesn't mean that there's no such thing as exponential or any of the other types of trends that you can. We're just going to look at the two of them. What we're going to do is we're actually going to be using a website to do our graphing. It's a free and very user-friendly website, www.desmos.com. I actually have it pulled up over here. When you go to desmos.com, you will actually see this screen, and you're just going to hit Start Graphing. I'm going to set this aside again. What we're going to do is we're going to go on here and we are going to input a table of values, and we're going to let Desmos graph those points so that we can see what kind of information is. Does it fit a line? Does it fit a curve? A lot of times when you have data and you're trying to come up with a model that is showing the pattern or the trend that is happening, you'll find that the more data you have, the more accurate your model is going to be. So that's a thing. I have a couple different things that you're going to want to copy and paste. And so in order to copy and paste these, the best way to do it is to go in Schoology under the Materials tab and select the folder Regression and Links. So I'm going to come over here for a moment, and I am going to go into Schoology and into Materials. The folder is at the bottom, Regression, Links, and Information. And I am going to select the linear regression file for Desmos. There's also one here for quadratic. This actually is going to bring you to a site that is showing an example of somebody that's done a linear regression model. If you scroll down, you can have a copyable statement that you can copy, which I'm going to do right now, just because it's kind of tedious to type this out and get all the subscripts and things like that. So I just hit Control-C. And then when I go into Desmos and when I want to paste it, I have it on my clipboard. I'm going to scroll down just a little bit more. If you are putting in the linear regression formula into Desmos, there's two things that you're going to see. You're actually going to see the trend line on the graph, and then Desmos is going to return to you some information. The really important parts of information that you're going to get are at the bottom, the parameters, where they're giving you the slope and they're giving you the y-intercept that you can go ahead and input into a slope-intercept form of a linear equation. You are given information that we are actually not going to be covering in Math 125, but I still feel like I should tell you what it stands for. Under statistics, you have the R variable, which is used to measure the strength of the correlation of your data. The stronger the correlation, the more linear your data is going to appear. And perfect would be like 1. So this is pretty close, but it's not exactly 1, and that's okay. The R squared variable is used as an indicator of how strong the trend line, the goodness of the fits the data. Again, if you had this at 1, that would mean that it fits it perfectly, which if you did collect data and it did fit perfectly, I would question it because really good data is not perfect. Good data is just not perfect. Okay, and so you'll notice that on the next page, we kind of go through the same thing with quadratic models, but I want to go back to that in just a little bit. So I know I'm kind of scrolling all over the place, but that's the type of way I have the notes because I want to make sure the right information is together. So if you go to page 24, I have an example here that is showing you data that's collected that is looking at students' studying time and the grades on their tests. So my hypothesis is that the longer a student studies, the higher the grade they would get on an exam. So before I can even answer any of these questions, I'm going to go into Desmos and I'm going to hit the plus sign and I'm going to select table and I'm going to input all of this information into my table. So I'm going to kind of put this over here, try to make it so I can fit both of these into the screen at once. For X, I have 2.3. The Y with that is 81, 1.7 hours. The student got an 83. 5.6 hours, the student got a 93. 3.2 hours, they got a 95. 2.1, I'm just going to keep on going with this. The half hour student didn't fare so well. 1.9, 85. Okay, so I have all of my data in Desmos. What I'm going to do is I'm actually, if you can see down here, there's another row that I can put information in. So my first row has my table that I inputted. My second row is where I'm going to paste in the formula that I copied. And notice that this information is here, but we don't see anything in our window. The reason we don't see anything in our window yet is because we have to kind of scroll around a little. The best way to think about this window is to think about MapQuest. And when you put directions into MapQuest and you want MapQuest to scroll in to where you're going to be, it can scroll out to the United States and you're not going to see where you're at. But if you scroll into the relevant spot, then you'll have it in perspective. Even better, because I have all my information right here, and I know that my X values vary anywhere between 0 and 6, and the Y values vary anywhere between 60 and 95, I could go ahead and hit this graph setting, and I can change the X-axis to zoom into the parts that are relevant towards this problem. For instance, if I start the X-axis maybe at -1, and put it all the way up to, let's say, 7. So I'm going a little above and a little below. The Y values, I'm going to start at 50, and then I'm going to put to 100. The Y values, remember, X values represents hours studied, and the Y values represent grade on exam. And then if I go ahead and look at what I have in Desmos, now you can see that this looks much nicer. And this is the trend line. And even though these points are kind of all over the place, they are showing a positive trend. So it's hard. There's a lot of outliers, and data is one of those things that can be very tricky. It can be easily manipulated. You have to make sure that you have good data in order to be able to interpret it properly. So this is what we have. We have a linear model that is y equals 5.44684x plus 69.756. So this is where I would go ahead and on my notes write in my equation. This was a linear model. Looks like the trend is line. Y equals 5.44684 plus, I'm sorry, x. Let me go back here a little bit. X plus 69.756. If you study for 3 hours, what grade would you expect to get? Well, we have a linear model now, so we could go ahead and we could plug in our grade for X. I'm sorry, you could plug in our hours for X, and after putting this in my calculator, we'll come back with the actual grade. So one way I can do this is put it in the calculator. Another way I can do this is by looking at my graph and seeing what I get looking at my graph. So when I'm looking at my graph and I scroll out a little bit, if I click and drag on my line, it's going to take me along the line at all of the ordered pairs that I have on here. If I could get it right to exactly 3 hours, I would have an accurate, oh, it's so hard. Maybe I will zoom in even more. The closer I zoom in, the better. 3. Ooh, 86. 86. There we go. We would expect them to get an 86. So I'm going to go back here and I would say that I expect that my student would have a grade of 86. Take a moment and following the steps that I just did, I want you to try the second example. Pause the video, put things into Desmos, get comfortable. If you have to rewind the video and kind of walk through this while watching me do the first example again, and that's okay. But that's the only way for you to be able to remember how to do this is to practice it. And the hypothesis here is that the length of somebody's arm affects their height. So pause the video now. If you have to rewind, do it. Do not just play through it and write down the stuff because you're not going to learn unless you practice. So now you're going to pause the video. Okay, so we're looking at number 2. Here are my pieces of data that I want to input into Desmos. So what I'm going to do in Desmos is hit the plus sign and table, and I'm going to go ahead and input my numbers, see if I can have these close to each other and see them at the same time. Let me scroll. There we go. 64, 69, 70, 62, 62, 63, 60, 70, 72, 71, 70.5, 69, 68, 65, 67.5. Notice that all of this data has come in pairs, so I don't have one column that's longer than another column or else it won't work. So that's a thing. So here we go, and I need to go ahead and grab my formula again, Control C, and paste it into the second row, Control V. Here I am looking at numbers that I'm going to have to really zoom out to see. I can go ahead and open up my X and Y axis values. My X axis I'm going to make go from 50 to 75. Remember that this is arm length. My Y value goes anywhere between, we'll do 50 to 75 for this one also. Just looking at my data to decide what is the best range to fill the screen. And this is height. And I'm going to click on here and you can see this definitely looks like a linear trend. These are going in a positive correlation. So, and if I look down at my numbers that I have, here is my slope and here is my y-intercept. Knowing that I have this information now, I can go ahead and say that this is a linear model. And that the equation of my line, if I pull that information from Desmos, is y equals 1.1936x minus 13.0233. It says, what is the expected height of a person with an arm span of 66 inches? I'm going to go ahead and take a look at my table to figure that out. So on my sheet, I'm going to say that a height of 66 is going to give me an arm span of 66 will probably give me a height of, here's my table, let's see where we're at. Let's see if we can find 66. Ooh, okay. Let's move this over just a little. .754 actually was able to zoom out a little bit more and get a little bit more specific, which is probably best. Okay, so what I want you to do is, again, I want you to stop the video, try number 3, see if you think that the information is linear or quadratic. If it is linear, I want you to use the linear formula. If it is quadratic, I want you to go back and copy the quadratic formula. So it could be either or. So the hypothesis here is that temperatures are recorded during a 10-hour winter snowstorm. So maybe we'll see if there's a relationship between the number of hours where a snowstorm has been happening and its effect on the temperature. So let's go to our Desmos table real quick, and I'm going to hit the plus sign, table, and I'm going to do my best to make it so I can see them both at the same time. Here we go. This time I'm just going to go right down the x-axis since it looks like it goes from 1 to 10. Get those in there very quickly. 26, 24, 18, 16, 10, 12, 14, 20, 23, 27. And then I'm going to go ahead and zoom in here. These do not look linear. They don't look linear to me at all, and I haven't even changed my graph yet to make it so that the data is kind of a little bit more that it fits the screen. If I was going to do that, I would go here and I would make x go from 0 to, I'll go a little bit past 12, and my y-axis I would go somewhere between 5 degrees and 35 degrees. I'm just going a little bit beyond. Remember that the x-axis is hours and the y-axis is temperature. And I'm looking at this and it looks kind of quadratic. So quadratic is either a smile or a frown. So I'm going to try to find the best curve of fit, not the line of best fit. So I'm going back into Schoology, and I'm going back into my folder that is regression information, and I'm picking quadratic this time so I can copy my quadratic formula. Going down here, this looks a little bit different. This is also written in the notes, just so you know. I just copied it, and now I'm going to go to the next row and paste it in. Again, I'm going to get now 3 different parameters because quadratic equations have a second degree in here, so that would mean that we would need all 3 numbers for all 3 terms. This does look quadratic, and if you look in the notes again, if you have a quadratic model, you would be plugging in A, B, and C for A, B, and C in a quadratic formula that is in standard form. So let's go ahead and write this down in our notes. Does the data appear to have linear or quadratic relationship? I'm going to go ahead and say quadratic. Find the line or curve of best fit. So we're using the curve. We're going to start off with y equals, and we are going to say 0.742424. This goes in front of the x squared, minus 8.11818x plus 35.0667. When you do this in WebAssign, it's very highly likely that they're going to ask you to just round it to the nearest tenth or 100, so you have to pay good attention to that. Use your equation to estimate the temperature at 12 hours. I'm going to go ahead and look at my quadratic on the Desmos. Take my cursor, try to find 12 to the best of my ability. I might have to zoom in. Yeah, go over here. Oop, there's 12. Trying to be as accurate as I can. 44 degrees, 44.558 degrees. 44.558 degrees. I'm just going to make sure. At 12 hours, temperature will be, can't just write an answer, I've got to write a sentence. So yeah, that's the thing. Let's take a look really quickly at what this would look like on WebAssign. So I'm going to go into WebAssign. I'm actually going to pull up this homework assignment. This is homework number 3. WebAssign is so slow. And the very first question wants us to find an equation for the model of best fit. Really important here. Notice it says use the first and last values in the table. Do not put all of these. If they tell you to use the first and last values, you're only going to have 2 rows in your table. So if I go to Desmos, new table, get my information from WebAssign, it's 2, -6, and 1422. 2, -6, 1422. I'm going to go ahead. I still have my old labels in there. I'm just going to ignore them. This is 2 points. 2 points are going to be linear. So that's not very much data, but enough that it's going to be linear. I'm going to go ahead and go back to Schoology so that I can pick up my linear Desmos formula so I can copy and paste it because I'm too lazy to write it out or type it. Going down here, copying it, going into Desmos, pasting it. According to this, I have 2.33333, -10.6. Just making sure that I use the right points. 2, -6, 1422. Yep. So I'm going to go ahead, and in here it says use the first and last round values to 1 decimal place. Y equals 2.3x minus 10.7. And then I'm just going to check and see if that was the correct answer. And it is. So really important. If it says use the first and last value, then that's what they want you to do. You have a few different ones that are on here that you're going to have to look at, but I wanted to do at least one of them with you.